Lovely. Hello. Can you hear me? It works well. Very pleased to be here. Vladimir Foltin, my name. I work for EASA. Most recently, I work for EASA certification of general aviation. So the Rotax question taken on board. Thank you. Anyway, very pleased to be here. We have a great collaboration with Austrocontrol colleagues in EASA. A lot of good exchanges. A lot of support from their side to our work, and also vice versa. Therefore, I'm very pleased to be invited here to present on behalf of EASA our joint work, because EASA is an umbrella agency in Europe, and our work is mostly collaboration with national aviation authorities and people. So there are three topics I would like to talk about today. Two were in the program, so there are no surprise. Future of GA roadmap, I will talk about it in a moment. Iconspicuity in U-space and beyond. Conspicuity, the word is very specific. Conspicuous means to be seen. It could be like beautiful colors, like we know in animal world, but it could be also done electronically, so you can see people through electronic means. And this we will be talking about. And also the risk the drones pose for the collision of manned aviation, especially general aviation and rotorcraft. But there is a little surprise for you also. I was able to collect some information, latest information about the Avgas problems. Many general aviation pilots, especially those flying with a high power piston engine, are concerned about the future. So there is something happening in there, and that will be presented as well in this presentation. So let's move forward, not lose the time. So EASA loves general aviation. Yeah, but are we winning the battle with bureaucracy? Guess what? I've heard it in the room, and I'm sure the same was said on Slido. By the way, greetings to those online, connecting online to this event. We will give you preference for the questions, so use Slido. You will be given the right to ask first. So we are not winning the battle. It's constant battle. Internally, convincing external stakeholders, we need to find a common language with many, many different stakeholders. That's an extremely difficult task, sometimes. Sometimes it's really enjoyable. But the general aviation is our DNA. There are plenty of colleagues in EASA with roots in general aviation. So we have a good understanding what it is about. We really understand. We involve those colleagues, and we convince, we have informal network inside and formal network inside to tackle the challenges of the GA. For example, you know, the face of EASA, John Franklin, safety promotion, he started in ballooning many years ago. Wendell is active instructor in aeroplanes. Alain Leroy was a champion in aerobatics. He is the chief expert reporting to the boss of the agency, future or the current. And he is also in charge of general aviation project in EASA. And myself, I'm a commercial pilot. I was instrument rated. I'm still instructor gliding and examiner. I'm passionate competition pilot in sailplane. So still doing a lot of flying. We live GA in EASA. We are not isolated from GA. So there was a GA roadmap, well known to you. This was a second edition, started in 2018, and these were our priorities at then, and many of them are still applicable today. We can commit on the number one definitely today. GA remains high priority for EASA. This has been recently confirmed by our senior management, and we are now developing the future, and I will present the future to you now. So before we go to the future of the general aviation roadmap, let's reflect on the achievements, successes, what has been achieved, what has changed in the past. Most important, I think, to every owner of aircraft, sailplane, balloon, part and light, we have downscaled the requirements in a way to be proportionate for the general aviation. So we do not anymore apply commercial aviation, big airlines rules for maintenance of general aviation. We achieved more working on aircraft than writing papers about aircraft status. And that was the goal. This is in place, and it's a big achievement. There was a lot of great feedback sometimes criticism from stakeholders, and EASA tried to reflect on it as much as we could. So that has improved. Basic instrument rating. In US, you could get instrument rating fairly easily. In Europe, it was not possible. This was a 7-year journey, 7 years, to get it in the rule. No, it's not easy in the European process. It's not easy in national process. But now we have a proportionate basic instrument rating for pilots. You have proportionate theory. You are not learning oceanic stuff for airlines. You are learning what matters, what saves your life in bad weather. So that's basic instrument rating. We are now working with stakeholders, including from Austria, on making it reality, so that authorities and schools are implementing it and training school. Balloon and glider rule books. This is achievement not only of EASA. EASA put 5% of resources into this work. The rest was done by Europe Airsports, two organizations within Europe Airsports, European Gliding Union and European Ballooning Federation. They put together, extracted everything relevant for balloons, everything relevant to sailplanes, put it into one document where you find everything what matters. If you fly sailplane, just take document that don't go to legal text. That's what you have. It's published in PDF. Great thanks from EASA for their work. DTO, famous word, declared. You do not need to be certified before getting operational. It was a well-used concept in aero clubs many years. There were no issues with it. So we said, okay, why not to continue with this safe way of doing things in general aviation? And now we have declared training organizations for training of light pilots, light airplane pilots, for training of sailplane pilots and balloon pilots. Part 21 light is a downscaling of the not safety standards, but the methods how to prove and provide for safety in aircraft world. We have developed the rule. We have now the rule in place, and EASA is just now in consultation process on acceptable means of compliance. So how to comply with the rule. There is a lot of declaration in the system, and in the future, it may not be national microlights, but it could be European declared microlights, something equivalent to LSA in in US, but better, because it doesn't kill the undercarriage or retractable undercarriage or variable pitch propellers will be still possible with this rule. So that's coming into force this August, and we are now in consultation of the fine-tuned text. ADSL, I will not talk about it too much. It's on the full second part of my presentation is about this. And AVO, EGNOS, many abbreviations, all weather operations. And EGNOS, it's augmentation system for your GPS to know that the position GPS is using is secure and precise. So it's an equivalent of VAS system in US. What we have changed there, we've changed the rule of operation. So now the single engine piston and twin engine piston IFR flying is more proportionate. There are better minima defined pan-European scale, which are corresponding to international practices. And there are also the ways how to plan the fuel and masses and everything more proportionate for this kind of operation. So we have put that in place too. We have a lot of work ongoing with European agency, our sister agency in Prague for space program called EUSPA, where we are together trying to implement instrument approaches based on GNSS signal to non-instrument airports. So in future, every small aerodrome could have a possibility for this kind of approach in instrument condition without any lights, without any infrastructure on the ground. This is now happening in Lahti, and 2 more airports in Finland are coming into place. We have 3 projects for that in Sweden, Netherlands, and I think Germany. We have 3 aerodromes in pilot project, and we are sharing the information widely, and it will be all public to allow everybody interested to have an instrument procedure for their airfield. What we want to achieve, we want to fly GA planes from one GA airport to the other GA airport directly, not going to Vienna, Linz, necessarily disturbing traffic flows and other things, and flying more environmentally friendly because you fly direct. That's what is on this one. So these are all achievements there. There is a lot of safety promotion happening. I will point to the middle one as a cartoon called Sunny Swift. It is a cartoon, normally one-pager, with a key message always. There are 39 editions of Sunny Swift cartoon. It's always a very simple message. I'm learning while translating. This is being translated to all EU languages. It's free to use. It can be copied, printed. It can be used everywhere, unless you just refer to Sunny Swift EASA, and that's okay. Please use it as much as you wish. There are quite some interesting materials available for your winter seminars or instructor lessons and things like that. Of course, there is a lot of season opener. This has been said by my predecessors. I've heard the previous presentation from Austro Control. So there are many other things we do in collaboration with our partners. Last but not least, on this point, there is a General Aviation Forum. As you can see on the screen, under the title, there was 11,000 and more pilots registered for this forum. And it's a forum you can freely register just by email. And then you can ask questions. And normally you get answers not only from EASA, but from many others. But also, when necessary, from EASA. This gives EASA opportunity to answer it non-legal way. It's not legally bound, but it is interpretation of the experts. And in 90+% of scenarios, it solves the problem without going to our legal colleagues or other legal colleagues. So please feel free to register. It's a community GA at EASA. You'll find it easy, and you can benefit from the information exchange there. Moving forward, so how to turn our vision of the future of GA into the reality. So how to make it happen. It's not easy, but we have been figuring out how to do it in EASA fairly recently. And let me introduce to you the future of GA roadmap. The name is going to be, or is already, GA Flight Path 2030+. And this is where we want to enhance safety culture, enable sustainable growth, and embrace digital future so that maximize the benefits of technology and encourage wider diversity and accessibility for GA to all, younger, older. Everyone should have a chance to fly if they want to fly. We should not be an exclusive club of middle-aged men, of course. So, why we want to do this? You may ask yourself a question. There are many challenges, and we are a safety agency at first, so I'll start with those safety messages. Some of these documents were referred to in the previous documentation. There is annual safety review containing not a lot of text, but a lot of useful information. You will find, if you fly airplane, on 5 or 4 pages, you will find the top safety risks for aeroplanes there and what phase of flies, and it's a high-level analysis, quite useful. For sailplanes, the same, I think like 3 pages. For balloons, similar. By the way, do we know what are the 3 most significant top safety risks for general aviation? Do we know? Can someone answer in the room? I'll help you if not. Oh, that's a good one. It's a good one, but we have it reflected in this document as a loss of control. We are being killed by loss of control. And now, surprise, it's top safety risks for aeroplanes, sailplanes, and balloons independently. So it's on top in each and every. So loss of control. We have to work with pilots being able to control the aircraft, not the skills only. It could be distraction. It could be many other things. It could be entering the bad weather and then losing the control. So loss of control is our top safety risk. Guess what? It's the second one and third one. Yes? Yeah, that's the symptom. Yes, you are tired, you have a long flight, or you have been busy at work, and you are fatigued, and of course, yes. But the collisions, airborne collision, mid-airs, is the second one, and terrain collision for balloons and sailplanes. So in the Alps, so where they hit the mountain and so on, because they fly so close. So collisions, be it mid-air or terrain collision. We will be talking about mid-air collisions later on in the second part of my presentation. So these are our safety challenges, but there are many threats around. The world is changing. We see it as opportunities, but some people call it threats. So we have aging population. Not many young people are interested anymore in aviation. Ask your maintenance organization. All young people work everywhere, but not as a technician. They don't, and if they start, they get trained and they go to one of the big brands of the automotive to work there. Problem. Then it's not that active. And then there is future problem, because in an airline, as a first officer, you can fly CPL, commercial pilot. But the same will go for the new vehicles in 3 to 5 years. And these start to compete. There will be a lot of new commercial pilots needed, at least with VFR. And of course, this will open a lot of problems on the market. Then innovations. We need to, if we want to have safer pilots with safe decisions, we need to put innovation into the cockpit. We know that properly integrated innovations help safety. We have proven this over the years. So there is a lot of things to be done. We have this challenge of sustainability in the future, climate impact. So how to integrate, how to make electric and hybrid aircraft reasonably good alternative to what we have today. There is a lot of challenging happening as well. And this is bridging the sustainable future, because there is a perception that aviation is the polluter. But of course we do, but the proportion is negligible. But we still need to show that we take the future, our future, into our hands. Otherwise, we have a problem. Just if you can indicate how many in this room are below 30. Just raise hand. You see? I hope the picture, it's very few. For those who are online, it's very few. But I hope the picture, online picture, is different. Because people like to connect to the young people, they just like to watch online things. I really hope so. There is more young people. We need to work so we have much more younger people in the room in the future. So these are threats, but we see them as opportunities. So what we want to do in the future GA roadmap? So we will not be doing new things, trying to reinvent the wheel. We have European plan for aviation safety, where in chapter 2 there is a whole text about general aviation. Not very long. Just find this, read it. It's 5 minutes of your time. You do not need to read all 200 pages of this document. That's enough to read here, general aviation chapter. If you want more information, there are references, and these are the tasks. These are what we can do as EASA together with member state authorities and stakeholders for general aviation. This is the list of tasks we will be doing beyond this year. We will do some rulemaking. There is still some simplification in FCL. We have some questions about flight instructors. There is this threat of flight instructors for sailplanes and balloons being limited in terms of age. So these are proposals we are getting. So we need to find reasonable balance and good answers, if not to implement these kind of ideas. There is a research, we'll be talking about it in the second part of presentation. There is a hell lot of safety promotion by our safety promotion team in collaboration with authorities, including Austrocontrol. Thank you very much, colleagues, for that. And we do some good work also with member states. We have been doing with member states, for example, parachuting operations risks and how to manage them, because there were quite some accidents in some member states with many fatalities. Due to parachuting operations. So we will try to improve. We were trying to introduce something which improves safety that will not increase the burden, because there were proposals to make it certified operation. And it would kill parachuting at all if we would go that way at that time. So this is what we will be doing. So no too much surprises there. But there we want to, next editions, we want to tackle those challenges and threats we have been discussing in the previous slide. So now the question comes how we want to do it. And we will be just building on the experience of GA roadmap. So we will use the same principles. We will have this formal, informal network of focal points, not on organization, it's just focal points being managed. And whenever there is a GA proportionality versus safety issue, we are being aware, we coordinate the activities, so we speak the same language on FCL, flight crew licensing, we speak the same language on EASA certification, which is our primary task, we speak the same language about medical, we speak the same language about air operations. So we want to have a consistent message towards GA, which is making the GA still affordable and good to go for future. There are four pillars out there. We will work on safety, mostly on safety culture, on sustainability, of course, making every effort to possible in a safe manner to introduce climate neutral technologies. In terms of digitalization, we want to have a connected aircraft, fully connected, and in terms of diversity, we want more ladies and girls, we want young people into aviation, but we want to keep affordability to everyone, including older people. Some older people, they have time, but they do not have a chance to afford flying because the fuel becomes too expensive and things like that. So we have to have an eye on that. We want to have a reflection of society in the GA, not just a snapshot of one group there. So that concludes my presentation, GA Flight Path 2030 plus. There will be more to come from EASA. Just watch the space, join the community, and you will be notified if there is something interesting popping up. I wish you are, all of you being connected with us through the GA community. Or you can just follow the EASA social media and you will get the information through this channel. Now moving to the second point of my presentation, it's about iconspicuity in U-space and beyond. Many new words there, maybe sometimes you hear it, you may not fully understand what it means. It was a difficulty for me as well, and I'm working on it. 1/3 of my time is this topic, so I hope I will be able to explain to you, and I'll give you one promise, you will understand what iconspicuity means and how it relates to the U-space. So just wait, and I will deliver on this promise. So, as no surprise, we start with safety data. This was all where it started. It was not drones. We were concerned about airborne collisions in GA or in Europe. So these are the safety data. You see, the green one is a number of collisions with fatal consequences. So it must be fatalities there to be accounted here. And blue is number of fatalities. So how many people lost lives. And it was in 2019, was 19, and it was growing and big concern. And not even drones yet. Analyzing it further, just for your attention, the last two buttons there, all were uncontrolled traffic. So we do not have a concern in controlled environment. We have a concern where traffic is not subject to air traffic control. And all were small aircraft, not big ones. Small aircraft were hitting each other. Many of them were rotorcraft. So where we need to act, obviously in these domains, we have to be proportionate in terms of where to act. So when we looked at the issues, we found four problem areas there. Many of those are probably not surprised, but I will use just examples to illustrate those problems. So ineffective sharing of traffic information. You report on a radio, after 1 minute your position is already obsolete if you do not have a tracking method. And this is a certified method how to report position today. It's from World War in last century. It's still good in many places, but is it good for dense environment? Second example, we have FLAM, and we have other devices. And they were not interoperable. They didn't work together. You could not see traffic on your ADS-B in receiver, which is FLAM. Or vice versa. There are like 10 different protocols used in the spectrum. The second problem area, congestion of uncontrolled traffic. Where it happens, you all know. Typically, Sunday evening, your airfield, everybody returning home, plus glider traffic, plus some balloons. It's very busy at the end of the day. Everybody is congesting, everybody is coming to the same point. And this, of course, creates more risky situation. But there is also another one. If we introduce controlled airspace, what is the behavior of GA typically? Mostly gliders, but also some microlights and things like that. They fly around because the airspace is, they don't want to talk to them, or it's too complex, or it's too busy, I need a clearance. So what they do, they fly around, but they don't fly very far away from the border. With the modern tools, they fly just next to the border. But what the other guy from the opposite direction is doing, the same thing. So every airspace introduces congestions of traffic because it's obstacle on the route. Of course, at that time, we were scared of drones operations, especially those beyond visual line of sight. So how it will work? So there was a concern there. And airspace inefficiencies, last but not least, we know that we rely on see and avoid. But do you know that see and avoid scientifically is around 50% effective? You don't see 50% of the traffic with see and avoid only. You miss 50% of the nearby traffic. And there is another airspace inefficiencies that in some airspaces, because it's all ICAO, in some airspaces you do not need to even show on radio, you do not need to be visible. It is good for many places, but we need to come up with something new. And we came up with a kind of ISIA concept that we need to act in two legs to be able and stable. So one on iconspicuity, one on airspace. So we, in given airspace, and to be able to ensure that people are connected to each other and can see each other. I will explain term iconspicuity on the next slide, but I want to conclude on this one. We immediately understood that if we want to be stable, we need to combine the two. Airspace with some kind of minimum visibility for the benefit of all. And we said that will be a key solution for us. But at the same time, we understood that we have to do it in a way that it will be fully compatible with future U-space, which is the, I will explain on the next slide, drones playground. If we would do our collision problem, if we will sort it out without being compatible with U-space and asking people to have a new technology for U-space, it would be disaster. So we said, okay, it needs to be solving everything here on this slide, and we need to also solve the problems with drones. So let me explain and deliver my promise on U-space. So this is not the definition, please. This is just concept explanation. It's a layer of airspace which can be introduced in any ICAO airspace class, which provides new ways of doing things so that drones can operate beyond visual line of sight. So the drone is not seen by the pilot with eyes. So drones can operate seamlessly without need to segregate airspace for drones. Because if there would be segregations for drones, it would be disaster for GA. So basically this means integration of BVLOS operations into the same airspace with manned aviation. And we have two samples. We have where manned aviation is operating as a controlled, subject to Austro control stuff. And then we have uncontrolled airspace where you don't need to be seen. You don't need to be visible. So that's about U-space. But what is iconspicuity? It's again conceptual, it's a vision. It's in-flight capability to receive and transmit information about other aircraft, weather, airspace, or support to navigation in real time with one single objective: improve pilots' situational awareness. Because if pilots are better informed, if they have good information, they will make safer decisions. And this is what we want to achieve with iconspicuity. You may ask yourself why we put this word conspicuity or conspicuousness, which is Oxford language correct word, in there. Because the conspicuousness, be seen, is setting the baseline. That's the foundation of everything. That's the minimum requirement. And pilots will choose additional layers of requirement based on their needs. So SIM card is the minimum for having a mobile network connectivity, but the services and apps we are using, it's our choice. We know what is good for us. And that's the same concept here. So, and by the way, you may ask yourself what is on the picture up there. And many may think it's the weather, but it's not. This is the uncontrolled traffic density in Germany on Sunday. And you see the white spots there are TMA Frankfurt. There. That's the white spot. There is the traffic density is this. And around is super dense. Super dense. And it's the same in Austria. It's not different. Don't be worried. All right. So I will now introduce you the way we want to introduce this Iconspicuity roadmap for GA and rotorcraft. So there is this first step, and there are only two. That's not a long one. So the first one is proposed solution for U-space. There is this new requirement in SERA, Standardized European Rules of the Air, that you need to be electronically conspicuous to U-space service providers if you are not subject to air traffic control. So in ECO airspace VFR, in Gulf airspace all traffic, you need to be conspicuous if the airspace will be defined as U-space there. So you need to be seen to the drone. And while you are seen to the drone, you transmit your position somehow. It doesn't say how, but that information needs to be received by the service providers who will deliver that information to drone operator who is responsible by law, by European law, to avoid collision hazard. So it's the mandate for the drone operators to avoid collision hazard based on the information they are receiving from U-space service providers who will collect this information from your aircraft. So that's important, and that's a step one. So our task was produce the solution for U-space. There is a second step in our roadmap. And the second step is built on the U-space solution. So when we have a solution for number one, we want to have this full set of vision of iconspicuity being realized so that we can get weather, NOTAMs, airspace activated in 15 minutes. I want to have it in the cockpit. I want to see all traffic around. I want to have weather there. And we all know that mobile phone can give you approximate position. Cannot we use terrestrial networks for helping us in navigation in case GNSS goes down? At least approximately. It's a useful tool, not to be lost. So these are all on our list for the step two, and we want to make it better there. But let's focus first now on step one. Few slides will be about step one. So how we got there, because it's now delivered. So we were developing this. We were tasked, okay, here is the requirement. Develop how this aircraft will be conspicuous. And of course, we have taken aircraft perspective. I hope you will like the affordability, but affordability, I will underline, from the end user perspective. So what is affordable to me, what I can afford, may not be affordable to my friend who is flying a balloon or paraglider pilot. They have different perception of affordability. So affordability to the end user, it's one thing. Technology today, not dreams, existing technology, single device policy has been confirmed. No duplicated, complicated devices. And of course, the last bullet point is also important there because that's the enable airborne collision step two. Moving forward, there is also different player in this requirement, USSPs, U-space service providers, because they will be gathering the information and handing it over to drone operators. What they said, we just need minimum necessary information. Just, we need to see it's a glider and it's moving there. We need to see it's rotorcraft or it's an aeroplane, and that's enough. And we need to have constant update of this information. But we want to have affordable infrastructure. We do not have money for radars. By the way, radar will not work in low altitudes. But we do not have money to deploy expensive infrastructure because drone operators cannot afford it. They have business, they are competing with cars. So many these companies are rather small companies. So the infrastructure needed for all of this needs to be affordable. And of course, in terms of resources, how we transmit the information from aircraft to the ground, because it needs to be on the ground, it needs to be pan-European. We cannot have one U-space requiring one technology and another U-space in Slovakia different, Bratislava, in Vienna different technology. No, we want to have one technologies or set of technologies that is available everywhere. You are compatible with your U-space at home, you are compatible everywhere in Europe. There was a safety requirement there. Of course, machine-readable, open standards. There were some manufacturers having proprietary protocols, and they were working with us to develop a standardized protocol. So this was an important consideration. Last but not least, it all needs to be suitable for low-level and urbanized environment. And this is why, for example, Mode S basic surveillance, which is just basic Mode S, cannot be used for this purpose, because it will not have, you will not have interrogations at low levels in many places. So that's about this development. These are all the partners. Slides will be available. I will not spend much time on this. Just one sentence, very important sentence. There were large European entities like European Commission, Eurocontrol, European Defense Agency, many others. There were smaller companies, two-man show from paragliding, helping us to work on this. So diversity of stakeholders was enormous, and they were all working on the same goal, to have developed what I will present on the next slide. So step one of Iconspicuity. So what we will be talking about now, before developing this, we also asked the question ourselves, based on the criteria which were presented on the previous slide, can existing mobile telephony technology be used to visualize aircraft in the sky? Can we make them conspicuous? And of course, when you ask the question, you give it to consortia, you get the answer. Yes, but, and we were of course interested what this but means for us. So let's dive into it. First of all, at that time, there was no legal certainty about the use of mobile phones in the air. Sometimes it was even forbidden. Airliners were forbidding it for good reasons. So if we want to use it in the air for electronic conspicuity in U-space, it needs to be legally certain. Second thing, are there enough standards from mobile telecommunications available to support this function? Are there frequencies coordinated? Are there roaming requirements ready? All of that missing. Can we use smartphone? Do we need a specific device? All of that was the question. So the answer is basically, as of November, there is a legal coordinated decision for aerial use of mobile telephony in Europe. So every nation willing to support mobile telephony in the air can implement it in a coordinated way now. Now is the role for telecom regulators and telecom operators to introduce this initially for U-space, but when they do it for small piece of U-space somewhere, it will unlock potential for all country, because it's the same system. It's the same network. They will not do different networks for different things. So that's about aerial mobile telephony. But now about ADSL, we said, okay, we need to visualize aircraft in the air. The requirement was to create minimum standard for making us visible to drones. We have introduced new specification in EASA called ADSL. L stands for light. And at the time we knew, okay, having the mobile telephony at the back of our mind, we said, okay, we need to simplify the things. And probably we need to base the position information, including altitude, only on GNSS. And what we said, okay, what is existing today? And there was ADSB out international standard, but that was too complex in some instances. So what we did, we have derived only the necessary, absolutely necessary information from ADSB out and created ADSL. Few tweaks here and there, like aircraft categories, including also new modern technologies like eVTOLs, but also base jump people or those wingsuit pilots, so to indicate objects in the sky in a different way than ADS-B. So that's the ADS Lite. Of course, it needs to be compatible with the future applications. So this is something very new, and that it got some traction all across the Atlantic and other parts of the world already. So they are very interested what we are doing on this point here. So there are, of course, ways how to transmit the information. So that was the message, that was the protocol. But how you transmit? So if you do ADS-B out, you are fine. There is no need. It was before we started, available, it's international, no issue. ADSL, you can do, and what we are saying, if you want to be conspicuous, you need to transmit ADSL via SRD860. SRD860 means Short Range Devices 860. This is a device in that frequency band. But there are 3 distinct frequencies which are used for traffic collision in Europe. And if you are transmitting on any of these 3 frequencies, ADS Lite message, you are compatible and you are fine with U-space. For example, FLARM and others, paragliders will move to ADSL very shortly, and they will be all visible and compatible with U-space just by software change. You don't need to buy a new device. That was our goal. But of course, there are some users who do not have FLARM, do not have old devices, and they cannot afford it. And for them, mobile telephony is an ideal solution. They want to have an app where they just run it and they are visible in the air. And we are working on this one. If you will be transmitting ADSL over the mobile phone, over the network, you will be pretty fine for U-space. So that's our ambition for this. What is new on all of this is first time aviation safety regulator is introducing for safety-related task, not critical, safety-related task, non-certified frequency bands, and non-certified technology, non-aviation technology. And that's a breakthrough, and it's a wide opening thing also globally. Okay, so let's summarize the step 1 quickly. I will just focus on the mobile telephony. It needs local implementation. Austrocontrol needs to work with the stakeholders and implement it here. And we at EASA, I'm in charge of working ADSL for mobile specification. We need to develop it this year so it can be available and known to every pilot so they can start to set up their devices to be visible in the air. And yeah, and quickly moving step 2 of the Iconspicuity roadmap. This is the full potential of Iconspicuity. We have research. We have just started a research task. All the objectives are there, but the output is in the blue. We will have a technology roadmap next year, defining full interoperability, so then you can, by any means of technology, get right information into your cockpit in real time. The roadmap is for May 2024, but I will raise your attention about April 2023, which is right now, and there is a survey out there, and I would like to invite you to participate in the survey. This code will be available, but you can find it also on EASA social media. You are invited to take part in this survey. It will not take a lot of time, and it's about supporting this research so that we can have an interoperable systems out in the air so everybody can see everyone else, including the drones. We want drones to see us, but we also, if you want to see drones, as the paragliders want, they should see also drones operating in the area. So, and I'm moving to the last part of my presentation. It's about Avgas update, and that's a surprise thing which was not in the program. First of all, let's briefly introduce what's the problem. The problem is that there are initiatives, be it government or environmental, to remove some toxic fuel additives from the aircraft fuel market completely at all, and to foster the unleaded fuels. And of course, that's a challenging task for certification to keep safely operating aircraft. So the questions are how this will impact EU. This is mostly in US. What are the possible solutions for aircraft owners affected, and how EASA can help? So very briefly, EU REACH agency identified this TEL, which is used for development or for production of Avgas 100 LL and more as a substance of very high concerns. And as a result, after 1st May of 2025, the use of this TEL in any product in Europe needs a prior authorization, which is, of course, a problem. And then there is the programs of unleaded fuel in Europe. There is this EAGLE program led by FAA, but supported by every stakeholder. And there is the GAMI STC, you might have heard. So the situation from EASA perspective, from European perspective, is that the FAA is leading authority on those engines, because we do not have any engine in our portfolio that is Avgas operated. We have other engines which are MOGAS typically or jet. So what we know also that there will be some exemptions possible after, there will be some exemptions applied for after the 1st of May of 2025. So some manufacturers have intention today to do so. Whether it will happen, we don't know. In terms of GAMI STCs, the question is if they will apply for EASA certification. Of course, we will do the validation work, and we will do it as expeditiously as possible, considering the complexity of the tasks. And other considerations that there are alternative fuels, UL 91 available for some engines, so there is an alternative. But there are some engines which do not have alternative at the moment, and that's around 18,000 aircraft in Europe. So quite some proportion. So before concluding the presentation, people should now start considering this topic, engine aircraft conversions, because there is this high octane unleaded Avgas could up about 20,000 in the future and more to your fuel bills over TBO time. So it may turn out to be more affordable to make conversion than just wait for this very expensive fuel to be available. The problem is that there is only one company in UK which produces these additives, and if they will not apply, we will need to ship this fuel from US, and that will add the cost. So, and it will be completely environmentally crazy thing to do. So this is strong message for consideration there. What we want to do at EASA side is to support, on top of support of GAMI and other applications for fuels, we would like to also review our CS STAN, which is simplified specifications for other unleaded fuels, whenever that will be possible, technically speaking. And I think that concludes my presentation. I went a little bit over time, I apologize for that, but okay.